Alright, now I've got an iPhone 6 here that has no backlight. And this is one of the cases where knowing the history of the device is extremely important. You saw me there, I was removing the upper shield over the CPU. So this phone didn't just come in with no backlight. If it had, that would tell me I need to go down a very specific road with troubleshooting, which I've been down, and I know, when a iPhone 6 spontaneously loses backlight for no apparent reason, it leads to a very, very specific signature failure in the iPhone 6. But that's not what we're going to talk about today, because that isn't the history of this device. The history of this one is Touch IC was previously repaired. So if you can see, that definitely changes the my thinking about what could be the problem here. So I'm not going to be looking at the backlight filter, which is right here, because it's not going to just spontaneously fail by itself. And then this diode, it's probably not just going to blow itself. And we've got the backlight driver chip here, the IC. That isn't just going to fail by itself. But this board has had Touch ICs replaced. And I know that on the back side of this board, there's a chip right here, just like directly over, I'm doing the outline of where the chip is at on the other side of the board, right? Directly over backlight driver. And as we can see, backlight driver is underfilled. It's got the Apple shit all over it, right? So what happens is the heat from changing the Touch IC heats up this black goop, which expands. And the heat also weakens the solder joints that are underneath this chip. Not just the joints that connect the chip to the logic board, but also the joints that connect the balls to the chip themselves. Like, that is another joint. Under every IC, for every ball, you have two different actual joints. You have the joint of ball to chip and the joint of ball to board. And it's actually the ball to chip joint that is the common point of failure. So, what's happened here is that this area has gotten hot because of the Touch IC replacement, and this black underfill has expanded, and that has popped one of the joints. There's 12 balls under this chip. It's a 4x3 BGA, and the underfill has expanded and pushed the chip upwards, which is then combined with the heating of the joints. It's caused a cold joint, I don't think is the right word, but it's caused like a disconnect between ball and chip in one or more of these joints. And I'm pretty sure when I pull this chip, we're going to see, because once the ball pops off of the chip, that pad then begins to oxidize. So we should be able to see pretty clearly that there's going to be one or two, three pads on this chip that are heavily oxidized and don't have any sign of solder on them. So I wanted to zoom out really quick to show you. I'm using a quarter over the CPU because the CPU is underfilled. So it's not so much to protect the CPU itself from heat, but I don't want to get the solder that holds the CPU to the board too hot. Because that is just going to result in balls of solder popping out and just a nightmare. So anytime you're working around underfilled components, underfilled BGA chips such as CPU or NAND or audio IC or whatever it happens to be in the phone you're working on, You want to use a coin as a heat sink, or some other form, some other method. I'm going to rearrange things. I can get my tweezers in a little bit easier this way. Alright, so I'm in here with tweezers and I want to see that chip wiggle. When I see it wiggle, I know it's good to come up and I can just pull it off. Alright, so I've pulled the diode up too, which that's no big deal. Just put it back in a minute. So I'm going to guess probably this ball, maybe this one, and maybe this one are going to be oxidized on this chip. So let's see. Oh shit, where'd it go? Alright, back over here. Oh, look at that. We got a bunch of them. Look at those. Look at how oxidized that is. All right, you can see this one clearly the solder was still joined. This is barely, this is not really connected well. That isn't either. This is a little bit connected up there, but you can see all these other pads. When I scratch on them, remove that oxidation, and you can see that, you get shiny again. And let me show you what it looks like trying to get solder to stick. So on this one, I can melt it and the solder kind of spreads around a little bit. But these other ones, here, I'll get some more solder on my tips. It's really not wanting to get on there. Like, I can get it to stick, but not really easily. Right, but then this one, or this one for instance, no problem getting solder there. But these, it's not sticking. Now, if I add some flux, because flux is important, you always want to have flux, so let's see what happens if I add some flux and try it again. Look at that. There we go, got it to take finally. See, it takes a little bit of scrubbing really to get these oxidized pads to take solder again. They don't easily just want to do it, even in the presence of flux. And the reason why I wanted to demonstrate that is it's a good example of why reflow is often not a good idea. I get, people ask all the time if they should reflow or replace a chip. And my thinking is, if you have any reason to believe that the balls have disconnected from the chip and oxidized, then you should not reflow. You should pull it off. So, if there's some cases where reflow can work, but they're very few and far between, and I'm not going to get into that. That's not the point of this video. But I just want to take that opportunity to point out why reflowing BGA chips can a lot of times be kind of pointless. Even if you do create the joint back, the chip to ball joint again, a lot of times it'll be really weak. You'll just be partially connected around the edge of the pad on the chip, and that's not really a robust repair. That's not something you want to send back out into the world. I'm just picking this black goop out, get it out so I can get my new chip in there and give air a place to flow and all that. Alright, get out of there, goop. Hate this stuff. And I guess it's good because it does prevent liquid from getting underneath ICs or, you know, on the ends of these capacitors, but it's a pain in the ass. So now I need to clean off all the solder on these balls over here. I'm gonna get those solder balls off. I don't have to make the pads perfectly flat, but I do want them to be, you know, knocked down. I don't want big balls on them. I want very, very little domes. Do not want big balls. Don't like the big balls. Alright, that should do it, but while I'm in here, I'm going to go ahead and add some, clean my tweezer tips off and added some leaded solder to them so that they are well tinned with leaded solder. I'm going to go ahead and tin both of these pads again for the diode just to make it go on a little bit easier. And I'll get this position, this diode. Need the line on it to point up in this orientation, which is like that. Alright, pick the rest of this apple goop out. Get it out of there. And get myself a new backlight driver. So the backlight driver I took off wasn't bad, it just had some oxidized pads under it. So really I could have reballed it and reused it and it would be fine. But you know, you've got to look at how much is my time worth? Do I feel like sitting here reballing a $1 chip, or do I just want to toss a new one on there? And the answer is, I just want to toss a new one on there. I do save all my old ICs though, like ones that I think are probably good. I wonder if there's a market for, like, if I could find some old Chinese guy that wants to reball hundreds of ICs for me. Keep them out of the landfill. Alright, so I'm gonna get this new backlight driver put on. Get this diode positioned where I want it. I'll come back in. So I've heated up that driver well enough that it's kind of started to flow under there, and that kind of tacks it down so it's not going to move. But I have to come back in and really get the heat on it to get it to fully, you know, the grounds and everything to melt and get it to settle into place. You can see it moving there. And I like to give it a little nudge. There, yeah, I saw it. It moved and then it went right back, immediately right back into place. So that's what I was looking for. Still got some apple goop over here on the sides. Pick that out. Yeah, that looks good. I think this is gonna work. Alright, let that cool down and get my test parts together here. Alright, let's see if we get backlight. Got nothing right now, but I'm not sure if that's my charged battery or not. Try a different battery. Still got nothing. I mixed up a bunch of batteries earlier, and I think only one out of all of them was charged. Still nothing. How many more batteries do I have to go through here? Alright, what is the voltage on these batteries? Let me see. Okay, this one has 4.3, so it should work. Ah, that explains it. USB cable's unplugged. Rookie mistake. Now, let's see. We're getting, yep, there we go. We got Apple logo. Alright, sweet. We're good to go. This one is a bit dim because I have the backlight box pulled off of this screen, just so I can use it with phones that don't have a backlight by shining a light through the back. But yeah, backlight is solved in this one, and in this case it was a kind of side effect of Touch IC repair, and that happens sometimes. It's one of many ways that you can have an issue with Touch ICs. It's one of many ways that you can have like a problem after the fact, and it happens to everybody. So, you know, if you're out there and you're just getting into this kind of work and you're doing Touch IC on an iPhone 6 and you have backlight problems, you want to be looking at this backlight driver first before anything else. And you know, I've talked to a lot of guys that do this kind of work, and it happens to all of them. Anybody that does Touch ICs and says, you know, they've never had a backlight problem on a 6 after doing Touch ICs, either they're lying or they just haven't done enough of them yet. It's one of many problems that can occur. Just soldering this shield back on. Don't tell me my nails are too long. They're my favorite tool and I'm not cutting them. Fuck you guys. Alright. I'm going to finish doing this out from under the microscope and end this video now. Thanks for watching and have a good one.